Okay, so my name is Akmal Hakim Bismi with the number metric B122320035. So I'm gonna do a presentation about Signal system. So this is our group members. So this project focus on applying signal and image processing techniques using MATLAB. It involves audio convolution, Fourier series composition, image transformation using FFT, and image filtering using Gaussian and Laplacian of Gaussian kernels. So in test 1, we recorded our voices and convert them with an impulse response using MATLAB. As you can see here, this is our recording, and this is our result. So this is how the audio will be played.
Hello, my name is Akmal Hakim bin Bismi.
Hello and Assalamualaikum. My name is Muhammad Zulfadli bin Zainal. Hello and Assalamualaikum. My name is Muhammad Zulfadli bin Zainal.
Hello, my name is Akif bin Aimi. Hello, my name is Akif bin Aimi.
Hello, my name is Muhammad Fahmie bin Hishamuddin. Hello, my name is Muhammad Fahmie bin Hishamuddin.
As you can see, this is very short audio. It sounds like nothing, or maybe a tiny clip if you turn up your volume, because it is barely audible. So the convolution is blurring the signal, so this means the signal is distortion. It essentially like blurring the signal, like creating mini echo or filtering it. Convolutions simulate how your voice passes to a system. If the system isn't realistic, the result won't sound natural. That's what. Okay, thank you for attention.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Akif bin Aimi. The metric numbers B122310113. 10113, yes. So I will explain about the Fourier series. I set amplitude to 10 for sound intensity with a sampling rate of 40,000 points per second. Each note lasts 0.2 seconds, limiting the melody to the first 10 seconds. Define the melody using the same example frequencies, calculating how many notes fit within 10 seconds and trimming any extra. Next, I recreating a song involve combining fundamental frequency with two harmonics at lighter amplitudes to create a more complex sound, layering the wave components and visualizing the harmonic components in spread plots. The complete song is plotted and played using the sound function, representing the harmonic components and the combined waveform with melody. And lastly, fundamental frequency represent the main tone. Second harmonic is double frequency, adding depth to the sound, and third harmonic is triple the frequency, giving the note a richer feeling. Full waveform of the first 10 seconds of the note melody played using the sound function. So that's all from me.
Assalamualaikum, my name is Muhammad Fahmie bin Hishamuddin. I will be learning about task 3, fast Fourier transform. First, we need to make a photo of your team members in your best pose. This will be your original image. Second is visualize your original image in four frequency domain using fast Fourier transform. Reconstruct the image back to the spatial domain. The goal is to understand how FT analyze image content in terms of frequency rather than pixel. So this is the original photo. Is what the FT will be applied to. This image is the spatial domain where each pixel value represents light intensity of or color. So this is a output fast Fourier transform that we use for coding. Like thing, this load the image file into the variable image. So line C convert the color image to grayscale since a FT works with 2D data. Line 10 is FT2 computes the 2D FT of the image. Line 12 is gets the magnitude spectrum. So line 15 and 16 FT shift move the zero frequency component to the center. Line 19 and line 20 enhance contrast or small details since the magnitude varies widely and makes frequency spectrum clear for human viewing. So lastly is line 24 and 26. At 24 to 26, return the shifted FT back to normal. FFT2 reconstruct the image from frequency domain back to spatial. And lastly, the output image F should resemble the original grayscale image. So this is the output that we get. The image is after applying the inverse FT, bringing it back to the spatial domain. If done correctly, it should closely resemble the original photo, proving that no data was lost during the FT and inverse FT process. Yeah, that's all. Thank you.
Bismillahirrahmanirrahim and Assalamualaikum. My name is Muhammad Zulfadli. So I've been given to do a task 4. For the task 4, the topic is correlation of two-dimensional signal. So inside the task 4, I have two tasks to do. The first is create a version of your original image using the Gaussian kernel. And then the second task, detect the edge of your original image using the direction of Gaussian, or the short form is log kernel. As you can see, this is the coding that I do and do some research on it and using a reference that been given. So this sigma value that I use is 5, 10, 15 and 20. So you can see the result. The first original image was very clear, but when I use a 5 value for Gaussian blur, it's a bit getting blur. When use a 10, it's much blur, and you can see the last one is 20. It will become very blur, and you can hardly to see any detail of the picture. So the second test is using the log. So you can see the coding, also using original image, but the filter is different. So I'm using the log as the question been given. So the sigma value I use is 1, 3, 5 and 7. So also you can see the original picture, it make it very clear, but when I use one sigma value, the image will be blank and or just a bit wide of the frame of the picture. When I use a 5, the detail of the picture will be not show in the dot of the white dot. And when I use a 7 log filter, the picture will be not showing, means the detail of the picture will not show. So now I'm going to show the simulation from the same method given, output that I put on the slide. Now I change. So the first output going to out is the original picture. Now you can see the output of the picture is, when using the 2 is not much blur, but for a bit, but 8 is getting more blur, but 12 is getting much blur. But I'm using the 12, not 20. You can see the difference, how much the blur going to be. I'm going to show you for the task 2. Also the same value sigma. Then if I change, the output also going to be changed. Alright, you can see here. Or you can see the difference between 2, 4, 6 and 8. So that's all for me.
To this project, we applied key signal and image processing technique using MATLAB. We observed how convolution affects audio signal and how harmonic build a waveform and how FFT transforms images into frequency domain. Image filtering also shows us how blurring and edge detection work. So the conclusion, the project objective were achieved through the application of signal and image processing technique in MATLAB. High quality audio images were successfully recorded and processed. So this project also demonstrates a creative composition using harmonic and effective use of MATLAB. Okay, thank you for attention. Alright, thank you.